Okay, today we're doing chapter 11, which is dealing with inverses. This is an inverse, y equals k over x. It's an inverse function. K is just a constant. And then you know y and x, okay? So this is basically, the parent function would be y equals 1 over x. Okay? So these are inverse functions. So let's look at the directions here, because the best example is going to be just looking at what we're doing on the homework. So the first one should be 3, 1, 3. So it says each ordered pair is from an inverse variation. So find the constant of variation. Well, this is the constant of variation. Okay? So, we're looking for k. So we have x and y. So just plug those in. So you get 1/3 equals k over 3. So what does k have to be? Well, if this is 1/3 and this is something thirds, k would have to be 1. Okay? But if I didn't know this is just a ratio, so we cross multiply. So you get 3k equals 3 times 1. So then 3k equals 3. Divide by 3 and you get k equals 1. Okay? Alright, let's do another one. I'll just do number 14. So 0. Now let's do number 15. So 10 and 5. Okay, so same thing. You got y equals k over x. So now just plug these numbers in. So you have 5 equals k over 10. Okay, and if I'm going to solve this, I need to get this 10 over here to get k by itself, so I multiply both sides by 10. Those 10s cancel, and you get 50 equals k. Alright, so the rest of these you're just going to solve this same way. Okay? Alright, so let's go on to this part. Okay, so is that the back or the front? That's the back. Well, we'll go back to the front in a second. Okay, so write the function that models each variation. Find z when x is 6 and y is 4. So here, you need these 3 equations. Okay, these are the three. So, this is when a function has three variables. Okay, so we use these three over here. Alright, so the first one says z varies jointly with x and y. Well, z varies jointly with x and y, that's this first one, so we need this first equation, z equals kxy. Okay? And so now we need to find k, because we're given x, y, and z. Okay? So we just plug those in. So we have x is 7, y is 2. We want to know what k is. And z is 28. So now we just solve this. So you have 28 equals 7 times 2 is 14k. And then divide by 14. 28 divided by 14 is 2. So k is 2. And so the formula would be z equals 2xy. And you're done. Okay? So the next one says z varies directly with x and y, or x, z varies directly with x and inversely with the cube of y. So z varies directly with x and inversely with y. So that's going to be that one. So I'm going to give you the formula and you are going to figure the rest out. So for number 24, so you need to use z equals kx over y cubed. And you guys are going to have to plug in the numbers for number 24 and solve it from there. I'm not going to do the rest. You guys can do it. But you need to use z equals kx over y cubed. Okay. So now it says each pair of values is from an inverse variation. Okay. Find the missing value. Well, on that one, what you're going to do is you're going to first find the y equals k over x. And find this k. And then you're going to plug the numbers in for the second one to get the answer for the missing variable. So let's do the first one. 25. It says 2, 4. So if we put 2 and 4 in here, y is 4 and x is 2, we get 4 equals k over 2. Okay? So multiply both sides by 2. And the 2's cancel, and k is 4 times 2, so 8 is k. So then now what you do is you go, okay, so then the formula would be y equals 8 over x. And so now you come here and you say, okay, well I want to know y, but I know x. So y equals 8 over 6. And that 6 comes from right there. Okay? And so y is 4 over 3, or you could leave it as 8 over 6. It doesn't really matter. Okay? That's all you're doing here. So first find k, then plug in what you know in the formula, and it'll get you the one that's missing. Y'all can do the other two. Okay, so on this one, it says, is the relationship between the values in the table direct, inverse, or neither? So This is direct. We already know that this is inverse. And then neither would be neither of those, right? So, let's look at the first one. So what you do is, you just take x and y and multiply them together. So, number 1, you have 2 times 10. That's 20. All right, I multiplied this number times that number. So now I'll do the next one. 4 times 5. That's also 20. 5 times 4, also 20. And 20 times 1, also 20. So, if these numbers are the same, then it is inverse. Okay, and this number is the k. So then the formula here would be y equals 20 over x. Okay, that's all you do here. So multiply the two numbers. If the two numbers are always the same value, that's your k, and then you just make the formula with your k. It's really simple. Okay? Alright, so let's see one that's not direct. So look at this one. This one has 1 times 2. That's 2. Then 3 times 8. 3 times 8 is 24. So 2 and 24, not the same. So it's definitely not inverse. So now let's see if it's direct. Okay? So if you look here, 2 is 1 times some number. So 2 is 1 times 2. Okay, let's try that on the next one though. 8 is not 2 times 3. So this one isn't direct either. This one is neither. Okay? Let's look at this one. 1 times 6 is 6. 2 times 12 is not 6, it's 24. So this one is definitely not inverse. Let's see if it's direct. Okay? 6 for y equals 1 times k. In this case, k would have to be 6. So then if k is 6, 12 equals 2 times 6? Yeah. 30 equals 5 times 6? Yes. And 42 equals 7 times 6? Yes. So number 3 would be direct. Does that make sense? Alright, so y'all go ahead and do those. I gave you all 3 examples. You should know how to do these two. Suppose that x and y vary inversely. Write a function that models each variation. Well, if they're inverse, then this 2, you would do 2 equals x or k over 7. And find k. So multiply by 7. 14 equals k. So then y equals 14 over x. And then it says find y when x is 10. Well, you just put a 10 here. Okay? So then y equals 14 over 10. So you can leave it as 14 over 10 or 7 over 5. Okay? You just do the same thing for the other two. Alright? And then this last one I want y'all to try and figure out on your own, doing what we learned. Alright, that's it.